Hello guys, welcome back to another video on the channel. So today what we're going to be doing is going to be something completely different from any video I have done in the past. However, it is actually somewhat similar to my math videos. So I'm going to be covering a branch of science, physics, and I'm going to be going over the formula for specific heat, which is a really important formula, especially right in physics, as it's something you don't really get to study beforehand. Okay, so pretty much the formula for this would quite simply put would be C is equal to, or let's actually increase the font size of this to probably 24, would be C is equal to, and let's half this, boom, C is equal to Q divided by M times, let's just put a triangle here really quick, change in temperature, which is also represented by delta, which is just a triangle, which is also represented by delta T. That is also a change in temperature, or what can be represented. So pretty much C represents, so C is equal to the specific heat. Let's write that down. Alright, Q is equal to the joules, which is the, it's a measurement of energy. And then, so M is the mass, usually in kg. So let's just put that usually in kg. And then delta T is change in temp. And this is also usually measured in just Kelvin, which is just K. So now that you know the basics of this, let's go on to the next spectrum of it by opening a new tab. Alright, so now let's go into kind of how to solve these equations and kind of how they work. So let's start off by having okay, so let's say the initial temperature of a or let's just write a word problem really quick, alright? So a cup of sand, which has a specific heat of XYZ, okay, takes, or no, a cup of sand with a specific heat, or let's just say cup of sand, heats up from, or let's do 2 kg of sand heats up from 10 degrees Celsius to, let's take maybe, it's a good number, I wish I could move this thing. Weird. It doesn't show it. Alright, never mind. Alright, let's just type this. Alright. So a 2 kg of sand takes I don't know. Heats up from 10 degrees Celsius, I'll just label it C, to 20 degrees Celsius. And yeah, how much heat is needed or is used for this? Alright, so now you pretty much have this equation. Now you also know that the specific heat of the specific heat of sand is 664 kg over K. So now you know that how much heat is technically in form of energy, right? Because heat is, by definition, it's thermal energy, which is a type of energy, and energy, once again, measured in joules. Whereas specific heat is the literal amount of like heat in joules over kilograms Kelvin, which pretty much means how many joules per blah 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 you need. All right, so now let's set up our equation. Alright, so let's write the given, because what you want to first write. The given is the mass is equal to 2 kg. Right, and then you also know that the initial the this is so sorry. And you also know that the initial temperature is 10 degrees Celsius, whilst the final temperature is 20 degrees Celsius, right? And then you also know the specific heat for this is 664 joules over kgk, which is kilograms Kelvin. Alright, so now let's actually do the plug-in for this. So if you actually just, all you gotta do substitution method, and then you actually do get the formula derived, which is Q, which represents the amount of joules, or the heat needed, is equivalent to all of them multiplied. So you have M times change in T, so I'll just do CT, change in temperature, times C, because C represents specific heat in physics. All right, so now let's do plug-in for this. All right, so you still have Q, right? You need to solve for that, is equal to 2 kg. I'll actually just write this spaced out, times, then you also have so for this, let's actually write something on the side really quick. So for the change in temperature, what you do is the final minus the initial. So then you can do 20 degrees, 20 minus 10. You're at 10. So now you may be wondering, all right, it must be degrees Celsius, but it's like the same thing. Even if you do convert it into Kelvin, it's still like 10 degrees Kelvin difference. So you can just put 10K. You don't need to put the unit or the unit just for the step where you're subtracting. But for everything else, though, in physics, you need to put the label. All right. So now we shall write the next part. So 2 kg times. So now we know what change in temperature is. 10 Kelvin, which is just capital K, there's no degree symbol, nothing, times 664 K. Alright, kilograms Kelvin. Right. So then, alright, never mind. Alright. So then what you can actually do is unit multiplier. Pretty simple. You have kilograms Kelvin is on the bottom, so you can also just cancel out. Right, actually, let's use a different color. Kelvin with Kelvin, you can cancel them out. Let's do that. And then you can also cancel out the kg with the kg. So what you have left is 2 times 10 times 664. And then here I forgot to add a label joules, which should be input right there. So joules. So then what this actually comes up to is 664 times 2, that's 8, 1, 2, 12, 13, 28. So 13, 28, and then you must add this 0 over here. So the amount of joules needed to heat this up would be J is equal to 13280. Now let's do another problem. So, now let's say you have. Okay, now let's do something else. Alright, so let's say you know the specific heat of an object. Let's say water, since the specific heat is 4184. Alright, so let's write the given is cup of water, or 2 kg of water. It's around 5. And I'll just do 2 kg of water. Initial temperature is 20 degrees Fahrenheit. Right, yeah, wait. Let's just do Celsius. Final temperature is 50 degrees Celsius, and the specific heat is 4184 divided by kg. Right, and then so now what you need to find is the never mind. All right, so let's say you don't know this, right, initial temperature, but you do know how many joules you have. So you have 418423 and joules of energy, and then as I previously put, 4184 divided by joules divided by kgk would be the specific heat. So let's label that as that. Let's label that as Q. Let's label that as M. Formula for this, it would actually be change in temperature. So let's just write change in temperature is equivalent to, let's take a different color here, is equal to Q over MC. So in this case, it would be 4184,123 joules, then divided by M times C, which is 2 kg times 4184 joules over kilograms Kelvin. Alright, so now let's do the unit cancellation. Let's take another color. Alright, so we can cancel out the joules and the joules. Right, you can also cancel out the kg with the kg, reason being that they're pretty much on the other sides of each other technically. Because if you imagine this, you should imagine all the division. So 4184 joules over kilograms Kelvin being in fraction form actually does make it way easier to actually do this unit cancellation. And then so what you are left with is 4184. Let's actually just drag this number on. So let's carry this. And then, never mind, that was a fail. I have no idea what the heck's going on. Just do. Alright. So you have this, right? And then so you can pretty much just go. Then so let's write these numbers here, the different color. So now you have change in temperature. So CT is equivalent to 4184,4000, and the joules is gone, right? Because we showed the unit cancellation in our work. I don't think I should have put 2 kg there. Oh wait, yeah, I should have put 2 kg divided by 2 kg. Or let's actually just put a line under here. This will actually make it way simpler. Right, to actually look at how you do this. 2, and a kg is gone. 4184. Alright, so now we can pretty much simply just get rid of some things. So first things first, let's change color. You can get rid of 4184 on pretty much both sides. So then you're left with 1000. Let's just put the 1 right there. Right, and then divide that by 2, you have 500. And oh yeah, there is a K actually bottom here. So let's actually just draw that in really quickly. K. Can't forget about our buddy K here. That's how we actually derive change in temperature. And then you can you get 500. So change in, or let's put delta T which represents a change in temperature, is 500 Kelvin. So this actually is pretty cool. However, these concepts do in the long term get harder, especially like in this equation. I just added zeros to 4184 to kind of show how sometimes it can be simple. However, this is most likely not going to be the case, unfortunately. It's probably going to be around a number like 9 million, 8 million, 5 million. So you're just going to have to kind of get used to it, doing these long divisions, and kind of making sure how to correct those and that you know how to do those. So yeah, guys, hope you did enjoy. If you did, please considering dropping a like and subscribing. And it's me. Adios.